So the last minor aspect of electrolysis in the redox HL topic is electroplating. So electroplating is a specific application of electrolysis where an object gets covered with a thin layer of a metal. Now, you should know some details about how you're supposed to set up an electrolysis setup. It's really not any different than a normal electrolysis of aqueous solution, except for a couple of specific details. So you have a battery or some sort of power supply, and you're going to have two electrodes in an aqueous solution. The details that are important for electroplating is that whatever you plan on plating in metal must be the cathode, because at the cathode is where we have reduction. So that's where the metal ions are reduced, at the cathode. So the cathode has to be the object to be plated. So maybe that's a piece of wire that's getting coated in more metal of the same or more of the same metal. So that could be how we build out copper wires with very high purity. Or you could cover one object in another metal. So if you wanted to gold plate something, the object to be covered in gold would be placed into a solution with gold ions, and it would have to be the cathode. The second thing that needs to be present is that the solution has to contain metal ions of the metal that you want to plate, because the metal ions are going to be reduced into a metal. So the solution needs to contain those metal ions. That one's fairly obvious. Now, the third part, technically you could do electroplating without this, but for like a paper one question, they would want you to list this also as sort of the third condition necessary to do electroplating. The positive electrode, the anode, should contain the metal that you are plating. The reason for this is that at the anode, we have oxidation taking place. And so if you have the metal in that anode, the metal will oxidize and fall off the electrode as metal ions. And so essentially what you'll do is you will replace the metal ions in the solution, which are plating onto the object at the cathode. So this keeps concentration of metal ions constant until you run out of metal in that positive electrode. So in this example up above, if you want to cover this object over here with copper ions, then having a positive electrode that's maybe made out of impure copper, or it could be pure copper, but probably impure copper, is really smart, because as the copper ions in the solution cover the negatively charged cathode, the actual positive electrode will be giving you more copper 2+ ions back into the solution, so that you won't run out of copper 2+ solutions quickly. It'll let you run this for longer. So the three conditions are: whatever you want to plate in metal needs to be the cathode. That's where reduction takes place. That's where the metal ions will be reduced to that metal that you're plating. You obviously need to have the metal ions in the solution so that they will be reduced and form that coating. And then the last one, which is probably the easiest one to forget, is that it makes sense to have the anode made out of some material that contains the metal to be plated. That way, the metal will oxidize into metal ions, which will replace the metal ions that are lost during the plating process. So that's electroplating. It's basically just an example of electrolysis of aqueous solution, but it's specific to coating an object in a layer of another metal.